Alright, hello once again. This is Jeff Scott of Rankin Technical College. And previous to this chapter, I've been going through several iterations of a payroll system to try to teach Java programming in accordance with the PDF that I have on the screen right now, starting out with Java from Control Structures through Objects, 6th edition by Tony Gaddis. I'm now up to Chapter 9 of 16, which is on text processing and more about wrapper classes. And I've decided to do a program that I have done before, not for you, but for other classes, and that is I'm going to create a palindrome program. So I'm going to take and save my last program that I was working on, which was from Chapter 7, and I'm going to close the project. All right, so it's going to ask me if I want to create a new project, which I do, but I want to come in here and I want to go to the desktop here, and under my payroll, I have a folder in here now called Palindrome Chapter09, and that's what I'm about to do. So, clicking my Create New Project button, you know the drill. Next, next. Give this a location. It'll be called Palindrome Chapter9. Finish. Right mouse click, oops, open up my source. Come on, right mouse click on source, new Java class, edu.rankin.jpscott. Now this will be different, palindrome. Okay, so there it is. And again, I'm going to write this palindrome program and a couple things. It's only going to have a main in it, so in a way it seems like it's regressing, but it's not. Hopefully it'll allow me the opportunity to talk about a few things that basically you have that are connected with wrapper classes and some of the other stuff. So, was it PSV? Is it PSV? PSVM tab. There's my main. This is not really a long program. But let's put a comment up at the top anyway. And it will say, this program will let the user input a string of characters and will let the user know whether or not said string is or is not a palindrome. A palindrome is a word that is the same forwards and backwards. Example, Bob is a palindrome. This program is meant to demonstrate the use of some of the character-based methods from Chapter 9 of our Gaddis PDF. Okay, that's more than sufficient, I think. All right, so the first thing I want to do in here is I want to create, I should say declare, and initialize program variables. Now all the variables that are in here, they're all in main, so they're all local. I'm not even going to say that, but they're all local. All right, first thing I'm going to have is an input string, and I'm going to set that equal to the empty string. we'll just say original input. Since I have an input string, I'm also going to have an output string. And that'll be used for show message dialog. Since I'm going to be using show message dialog, why not just add the import statement right now? Import javax dot swing. Now I can say dot star, or I can just say dot j option pane, which more than suffices for right now. All right, let's go on. I'm going to have, let's see, I'm going to call this string. I just call it the string. How about this? We'll call it letters only. And that will be input string with only the letters. And then I'm going to have another string that I'm going to be called, I'll call this rev string. And we'll say that this is letters only string reversed. All right. We'll have another string, and this is something we've done a lot in Java. We even did it in C#, I think. We'll call this do again. We'll set that equal to the empty string. And this will be the user reply to run program again or not. All right. We'll have a char in here. This will be first char. And this will be the first character of do again. And we'll check that in just a bit to make sure. Whoop, that's got to be single quotes, I'm sorry. All right, and we'll check that to see if it's a Y. All right, so we'll have a Boolean. Oops, that's interesting. That will be called run flag. And we'll set that equal to true. And that Boolean is the program continue variable. Okay. Finally, we'll have a new type of variable we have not seen before. It'll be of type string builder. And we're just going to call this SB for string builder. And that's going to be equal to new string builder. All right. We've used strings for everything else. Strings are what are known as being mutable. So in other words, if I come in here and I'm writing something in Java and I type in this, you may have seen me do this stuff before. String first name equals Jeff. All right. Now, somewhere in the memory of the computer, and no one knows really what memory looks like, so, but somewhere, if you could imagine that somewhere in the memory of the computer, oops. Okay, something like that. If you could imagine that the memory of the computer is kind of like a lot of mail slots, for lack of better words. All right, and it would be a lot bigger than this, but let's just imagine that we're at about right here where this is, right there. Whoops. We're at location 10,000. So starting at location 10,000, I've now got a J here, an E here, an F, an F here, and an F here. Now, you know as well as I do that the only thing that the computer can understand are zeros and ones. So it's not going to really be JEFF, okay? It's going to be the zero and one combination that represents JEFF, etc. But just for this demonstration, so now later on in my program, so ... means somewhere else later in the code, I say first name equals Jeffrey. All right? The system doesn't just automatically come in and add an R here, an E here, and a Y here. It goes to a different part of memory. So let's suppose that it goes back to location 100, and it puts a J there, an E there, an F there, an F there, and just imagine, it's not going to overwrite this, but let's just keep going here. An R, an E, and a Y. So it does something like this in a different part of memory. Then it says, hey, you know this stuff? It's not being used anymore. So mark it as being free so that it can be claimed by what's called the garbage collector. All right? Well, what I'm trying to tell you, what I'm trying to get across is when you take a string and you change its contents, where those contents live will automatically change because that doesn't keep its location. It's not what's called immutable. On the other hand, a string builder is immutable. So you can make changes to it and it stays right where it is. So in that case, it would be as if we came in here and just added the R and the E and the Y. All right? Okay. A little bit more than you probably cared to hear, but I just wanted you to hear that. It's also why if I do this, if I say string first name equal Jeff, let's call this first name 1. And then I say string first name 2 equal Jeff. Well, somewhere in memory, we get this, somewhere around location 100. But then somewhere else in memory, and again, I'm just randomly picking a location here, so let's say at location 10,000, 20,000, 50,000, it doesn't matter. All right? But let's suppose this is Jeff and it's at location 100. That's that one. And this is that one right there. So if I were to come through here and say if first name 1 equal first name 2, that does not check to see if the contents are the same. It sees whether or not first name 1 and first name 2 point to the same location in memory. They do not, so this is false. On the other hand, if I say this, if first name dot equals, and I do it like that, now instead of checking where it is in memory, it's checking the contents. So it is saying, is this the same as this? So that one is true. All right, just a few things to keep in mind regarding strings. So string builders are mutable. You can change what goes in them. All right. So I'm going to start this by putting this into a loop that says while run flag. And remember to say while run flag, that's a shortcut for while run flag equal true. Means the same thing. All right? It's a shortcut, not a shortcut. All right. So I'm going to come in here and I'm going to say output string, output str plus equals. I'm going to build an output string. It says please enter a string and I will tell you whether or not said string is or is not a palindrome. Same forwards and backwards. I don't want a backslash n there. All right. So now, input string equal J option pane dot show input dialog. No. Output string. So if I were to run the program right now, and I'm not going to, but if I did run the program right now, and I'm not going to run it now because, well, we can do this. So we'll say here, run flag equal false. Okay, that should only run it once. So let's do a file, save all, and let's run it. All right, so there is my please enter a string, and I will tell you whether or not it is or it is not a palindrome. All right, fortunately, as soon as I do that, it hides this. So that's this. So I'm just going to put in anything, it doesn't matter. Click OK, and I'm done. But what I wanted to show you was, when I ran this stuff that you see right here, let me move that up. So please enter a string and I will tell you whether or not said string is or is not a palindrome. Same forwards and backwards. So that's this. That's the output string that I'm using as the input to input string. All right? All right. And I'm going to grab that run flag, just comment that line out. Okay. So now what I want to do is I want to run through the string. So let's put a comment in here. Take input string, which again is input str. Let's make this a multi-line comment. So I want to take the input string, and remove all non-letters from it. All right. Then take the revised string, the revised letters only string, and reverse it. Compare the reversed letters only string with the letters only string. If they are the same, you have a palindrome. Otherwise, you do not have a palindrome. That's the logic of the whole program. All right? So I'm going to put this into a for loop because I do know exactly how big this string is. For int LCV for loop control variable equals 0, so I start at the beginning, and while LCV is less than input string dot length. So notice it'll go and it'll figure out for me how big that input string is. Plus plus LCV. All right. Okay. If the current character, now we used integer.parseInt, we've used double.parseDouble, I've used byte.parseByte, I've used boolean.parseBoolean. This is character.isLetter. And what character? Well, the input string dot char at LCV, which means check the current character in input str. So if it is a character, then I want to add it. Remember, I'm building a string, and that string that I'm building, I want that to contain only letters. So I want to put it into letters only. But I want to put it in there a character at a time, so I use my string builder. So SB, my string builder, dot append that character, which is right there. Now, do I expect that to make total sense? No. So let's take a look. So let's say that I come in there and I put this in there. I put in hello 1 2 3 comma 0, and then let's 0 LLEH. Now, the way I'm writing this is going to be a palindrome. All right, because it's going to put into my string builder the H, the E, the L, the L, the O. It's going to skip the 1. It's going to skip the 2. It's going to skip the 3. It's going to skip the comma. It's going to skip the 0 and put in capital O, LLEH. And eventually, I want all of these to be this, I don't want them to be different caseness. So I will change the caseness so it looks like this. Then I will reverse that string. So this will be my letters only. Then I will reverse it, which is HELLOOLLEH. This will be my reversed string. Then I will compare those two, and I will say if letters only dot equals reverse str, and if that's the case, we have a palindrome. That's the program in a nutshell. So, if this is the case, what do I want to do? Append this letter, this alphabetic character to the string builder. Okay? And that's all I want to do in here. When I'm all done, all right, now when I've gone through this whole thing and I'm out of the for loop, now I can say letters only equals SB, the string builder, dot, but I have to do a toString on it, all right, because technically a string builder and a string are different types. So copy the completed string builder, which is SB, to letters only. All right. Next, I want to make letters only all uppercase. I could make it all lowercase. The point is, it has to all be the same case. So, letters only equals letters only dot to uppercase. All right. In fact, before I do that, let's see. Well, now I've got that, so. Yeah. All right. Reverse letters only and copy the result to, what did we call this? Rev string. So, rev string equals letters only dot in fact I can't do it on here. I think I have to do it on the SB right here. All right, so I'm gonna actually move that up. Oops. Okay, so rev string equals our string builder dot reverse dot toString. Oh, what doesn't it like here? Oh, it's because reverse is a method. Okay, so reverse that, copy it to rev string. Okay. I wonder, can I take my string builder right there and can I make that uppercase? So I'm going to try that. I'm not sure. I'm rewriting the program that I had done earlier. So make string builder all uppercase. SB equals SB dot to uppercase dot to string. Says that we cannot resolve that method because to uppercase cannot be put onto, can I reverse that? Well, can I set letters only equal to that? Which cuts down on the code I have, which is good. So make S be a string, convert all characters to uppercase, copy the resultant string to letters only. All right. Now reverse letters only. Okay, so now basically what I did, using the example I showed you earlier, was I was building it a character at a time, right? So this would be input string. As I ferret out the characters I don't want, that becomes letters only. Then I take that and make it into a string, and I uppercase it. So this literally is our string builder. Then this, that becomes letters only. Then I reverse it, which is the exact same thing, and that becomes rev string. All right, that's what I'm trying to show you. Okay? All right. So, compare letters only to rev string for palindrome check. So if rev string dot equals letters only, all right, and they both should be all uppercase, so I don't have to do anything about caseness. J option pane, show message dialog, null, the string is a palindrome. That looks like that's sufficient. All right, so I want to say that it is. Otherwise, I want to say that it's not. Else, oops, I don't need that. So otherwise, it is not a palindrome. All right. All right, that's going to work, or at least I think it is. But I've got to, remember it's in a loop, so I have to ask them if they want to do it again. So do again equals, I need another J option pane, dot show input dialog. Sorry, I'm looking at my notes here that I've totally rewritten this program in. Okay. No. And we want to put here do you wish to run the program again? Yes or no? Good enough. And then the first character will be equal to character dot to uppercase do again dot char at 0. This is very similar to the way we did this in JavaScript. Check the first character. If the first character is not equal to a Y, notice that since we're doing a character operation here, not a string operation, we can use our equals. All right, so if that is not equal to Y, and we'll just normally exit. Now, what I want to do too is I want to come back at the end here and I want to reset the string and the string builder variable values. So I want letters only to be equal to this. I want rev string to be equal to that, and I want SB string builder dot length I can't say this, I can't say equals 0, all right, because that is literally a constant, but I can say here set length, and I can take that 0 and put it in here. That should work. All right, so let's give it a whirl. File, save all, run palindrome. And I'm going to actually use the same thing that I put in here. All right, so I'm going to grab this. And it says it's not a palindrome. Ooh, that's not good because it is. Yes. Try Bob. Bob is not a palindrome. Something is screwed up then in my logic. How about this? Yes. Let's put in Mary. It says that's, so it's telling me everything's not a palindrome. All right. Do I want to run it again? No. Normal program termination, and I'm out. All right. If the reverse string equals letters only, the string is a palindrome. Rev string equals SB. In fact, I shouldn't have to do this. I should now be able to do this. Equals letters only. Maybe that's my error. Let's check. So let's run the program again. Paste that in. It is a palindrome. Good. Do it again. Yes. Bob. Bob is a palindrome. Do it again. Yes. Bob. B-O-B 1, 2, 3, 4, 5, 6, 7. Comma, comma, comma. And that is a palindrome. Do it again. Yes. Mary. Well, notice I've got to fix this too. Mary. All right. Oh, it says Mary is a palindrome. Well, that isn't good. Now it's saying everything's a palindrome. This has got to be reversed. Well, can we do this? I'm going to have to take a break right now because I've got to go over to the St. Louis campus. Trying to figure out what my error is here. Well, one thing I want to do is down here, I want to set output string equal to the empty string, and I'll even do input string. Shouldn't have to do that, but I'm going to set that equal to it also. That's going to fix part of my problem. Let me do it a different way, real quickly. So I'm going to say here, letters only equals this to string. We'll leave it like that, okay? So make, all right, so we'll do that. And then we'll say rev string equals our string builder dot reverse dot toString. All right. And then we will take the letters only and we'll say that's equal to letters only dot to uppercase. Okay, I'm doing the same thing that I was telling you I was going to do before. I'm just changing around the order. Now when I compare these two, I'm going to say equals ignore case. Okay? All right, so I'm telling it now I don't care if it's uppercase or lowercase. So let's save all and run it. Bob is a palindrome. Yes. Mary, it's not a palindrome. Good. Let's try the big string we put in there before. Oops, not that. Okay. Run it one more time. And we want not that one. We want this. Copy. This should be a palindrome. And it is. Let's put it in there one more time. Yes, we want to do it one more time, but we'll put a letter in there at the end. K. Now this should not be a palindrome. All right. Looks like it's working. So very quickly, what I changed was, down here, I said letters only, so I copied. I made S be a string, and I copied the resultant string to letters only. That's what I did here. Then I copied the resultant SB reversed to rev string. All right. Then I reversed. So I did a, let's see. Then I made letters only all uppercase. All right, so then I compared letters only to rev string for the palindrome check and ignore uppercase or lowercase for each letter in letters only. All right, so those are just comments. It's about 100 lines long, and that's with, starting really here, so it's about 90 lines long, but notice I've got a lot of comments, so it's probably about 65, 70 lines in length. That is it for the program that I've done for Chapter 9.